Okay. Okay, well, good evening, ladies and gentlemen, and welcome to this monthly lecture and meeting of Astronomy Ireland. You're all very welcome. I've seen people signing in from counties all over the country. Tonight, we have our main speaker, Andy Briggs, who's given several talks to Astronomy Ireland in the past. He's going to be talking tonight about the moons of the solar system. I had a quick search there. I believe there are 288 moons of the solar system, nearly 500 moonlets of little asteroids and the like. So he has got a lot to talk about. But we always like to tell you a little bit about what's been going on in astronomy in Ireland. My name is David Moore. I'm the editor of our magazine that you can see here, which hopefully many of you get. If not, we'd encourage you to sign up. Great for families, packed full of Irish stories and Irish photographs. And I'll be telling you a little bit more about that, what observations we want you to do in the coming month, because it's an absolutely packed month. When we get to our speaker, we're going to let you ask questions in the chat box, or you can turn on your microphone and ask them that way. But at the end of his talk, what we like to do at these meetings is tell you a little bit about what's been happening since our last meeting, then our main event, Andy Briggs and his lecture, and then a little bit what was happening in the future. And boy, is there a lot happening this month. August is a humdinger of a month. Just as this night start to draw in, sunset comes earlier, everything seems to be going on in the sky. And I might just start a little bit about that while we're waiting for Andy to join us and tell you about the giant sunspots that have appeared. And some of you may have these eclipse glasses that we sell on our website. Astronomy.ie/sun will get you straight to the page. If you've already got them, I could see two sunspots with these, no optical aid, just in front of my eyes today. So there are two giant sunspots on view at the moment. And if you want a little tip, you've got a pair of binoculars. Here's something you can do. Take one of the caps, like I did, cut a hole in it. And this is a bit of blasphemy, but cut your eclipse glasses in half, cut a hole inside your binocular dust cap, and very strongly secure one half of the eclipse shade over the front. Then you've got an automatic pair of solar binoculars. And make sure the caps are on really tight, sellotape them in place if you're in doubt, especially if you're going to pass them around with the kids and the like, you might just pull them off. And now you'll get a 100 times better view. These are just 10 by 50 binoculars. So things are 10 times wider, 10 times taller. That's 100 times more detail. And then handy little tip. So if you're ordering eclipse shades, you can either order two pairs and cut one up for your binoculars. But I can see dozens of spots with those binoculars when you hold them really steady. That's my little tip for the coming week. We must put that into a little YouTube clip and put it on our YouTube channel. But what does Astronomy Ireland do? For those of you that are new, we're the National Astronomy Society. We're pretty sure we're still the world's most popular astronomy society. That's because we're always looking for beginners to join us. We publish Astronomy Ireland magazine every month. The club was formed in 1990, so we've hundreds of issues of this under our belt now. And as well as that, every month to tell you what to see in the sky and report what people have been seeing, we have a weekly email that goes out to paid up members only. So many of you will be getting that. So do join. If you're already a member, tell all your family and friends to join. We want as many people to join Astronomy Ireland as possible to keep us as the world's most popular astronomy society. And there's lots coming up that I can tell you about. So we're going to talk about, after the main talk, the Perseids, the fact that Saturn's going to go behind the moon. There's a double planet in morning sky, and there's a massive aurora at the moment. We can watch it from space with special spacecraft, and it's been extremely active, nearly as active as the one on May the 10th. And you may remember that we produced a special souvenir issue of Astronomy On magazine with the best of the thousands of photographs that were sent in on May the 10th. NASA said it was the strongest aurora of the last 500 years. And the one incredible thing about it on top of that was that it was actually clear almost all of Ireland, something which is as rare as the aurora themselves. So if you didn't get that, if you join Astronomy Ireland now, we're actually going to send the June issue, our souvenir aurora issue, to any new members that join in the next month till till the Starbecue at the end of the month. And that's the other event, the big barbecue under the stars, where this year the planet Saturn will be the star attraction because its rings are almost edge on. We won't see them when they're exactly edge on next year because it will be too close to the sun. So this is your best chance for 15 years until 2039. We've also got the Northern Irish astronaut, Rosemary Coogan, who's just qualified an astronaut, is now waiting for a mission. You may notice on the cover of the latest issue magazine, we have Nora Patton, who's given many talks to society before. She's booked on a flight into space in the coming months and years. We haven't got the exact date yet. So it's all happening. So that's a little bit about what we do. As well as this, we run evening classes. We run watches with telescopes all year round, especially in the winter months, not so much in the summer when it doesn't get dark till too late. But we have the big barbecue to make up for that in August. It's the biggest star party in Ireland every year. Hundreds, up to 1,000 people will come along to that. Dozens of giant telescopes, thousands of times more powerful than your eye, in a really dark sky to see the wonders of the universe. But exhibitions, talks, it's a fantastic event for the whole evening. And we also maintain a big media presence. Some of you may have heard us talking today. We're on the BBC. This morning we're on national radio. It's been the same all last week, talking on the Sean Moncrief show. Been lots of interest in the Perseids that I'm going to talk about after our main speaker. And in fact, if we go back to our last meeting, which was given by Dr. Paul Fellows, and he spoke on where are all the sun's sister stars. So we know the sun was formed in a giant cloud of gas and dust, and it wouldn't have been alone. So where are all the other stars it was born with? Well, he gave an explanation on that, and you may have noticed we're recording this talk. We record nearly all the talks, even the Starbecue ones. So you can find them on our website. The shortcut is astronomy.ie/DVD. You'll still get them on DVD, but anyone gets the DVD, we also send them this Zoom link so they can watch that way. I see our speaker is just about to sign in, so I'll wrap this up fairly quickly. Other than to tell you what's happening since the last meeting, well, the International Space Station was blazing across the sky until the 24th of July. I saw it several times. We issue free predictions for that on our social media, Facebook, X, and Instagram, so do watch out for those. It won't be in evening skies again until September, but we'll keep you updated there. That's where we also post aurora alerts, as we've been doing for decades. So whenever we think there's going to be an aurora, we'll tell you. We've been doing that actually several nights, Friday, Saturday, Sunday. At last, it happened last night, unfortunately, just as the sun was rising in Ireland. But we're hopeful it's going to last, and I'll check that during the talk to give you the very latest news after Andy Briggs has given his talk this evening. Another quick tip for you, if you can't get enough astronomy, tonight BBC4 has The Sky at Night. They have Dr. Nicola Fox, who's born in the UK, and she's now NASA's head of science. So they'll be telling you a lot about what NASA's getting up to, a huge amount, of course, and also inspiring young people. Keep up the interest and perhaps go on to be the next NASA's head of science. So, Laura, is Andy all set, do you think? Oh, Andy, can you hear me? Earth calling Andy in Spain. I see he's doing a test on sharing the screen, so I hope this is going to work. It is. And while he's doing that, I'll just introduce him. Andy has given many talks to Astronomy Ireland. He's an astronomy and astrophysics communicator who now lives in Spain, which is where he runs his YouTube channel, Space Oddities, where knowledgeable people talk about the very latest astronomy and space exploration, news, and discussion. He's been active for many astronomy societies in the UK and is a frequent contributor to Earth and Sky and our own Astronomy Ireland magazine, of course. He's also given many lectures all over the world now online, and he's given several talks to Astronomy Ireland. We've always enjoyed it. We always invite him back. I'm sure we'll have him again in the future. But Andy, if you're happy that your technicalities are all sorted out, thank you very much for giving this August talk of Astronomy Ireland. Over to you. We're not hearing you yet, Andy, if you're talking.
Okay, can you hear me now?
Oh, I can hear you now, Andy. Yes, a little bit faint.
Right. Okay. Just let me try and sort that out. I do apologize. I'm having technical difficulties this evening. Right. Okay. So now let me just share my screen. 1 second. Okay. Can everybody see that?
Yes,
Yep.
I can. I can see it okay.
Okay, great, fantastic. So apologies for the delay. I must say it's very nice to be back with you all again with Astronomy Ireland. I hope everybody's well out there and having a fantastic summer. I am. I'm having a very, very hot summer, as you can imagine, in Spain. It's getting to be a little bit too much now. I've had the fun, so I'd like it to cool down a bit now, please. But we did go out Perseid watching last night, and my daughter was thrilled because she saw more than I did, so she was absolutely chuffed. We're going out again tonight, so let's hope we see more. Anyway, moons of the solar system. This is what I'd like to talk to you about this evening. Before we do, can I just say thank you for the invitation to David and everybody, and thank you for the introduction. This is what David's talking about. We'd love you to join our communities at Space Oddities, and it's basically youtube.com/@spaceodditieslive, where we've got a good astronomy community going. We have a live stream which usually lasts an hour and a half, 2 hours on a Tuesday evening at 8 o'clock UK time. And we have a team of international astronomers, both professional and amateur. And we'd love you to join us. We talk about all sorts of things. We've got more than 400 videos about the universe on our channel now that we've made. So we'd love you to join us. But enough about that. That's the plug over with. Let's move on to the subject at hand. Now, there are, believe it or not, 293 known planetary moons in the solar system. And when you add on to those that are orbiting asteroids and dwarf planets and things like that, you can probably add several hundred, if not thousands, onto that. So we have a solar system that is absolutely replete with moons. And the reason I decided to talk about them this evening is that I find a lot of them absolutely fascinating due to their sheer variety, what they can tell us about the solar system, both the present solar system and the ancient history of the solar system. And there are some amazing worlds out there. So this is what I'd like to talk to you about tonight. Would you like to go on a tour of some of them with me? Of course you would. So what we're going to do, we're going to take a wander through the solar system. I advise you to, put the cat out, leave a note for the milkman, put your answering machine on, because you're going to be gone a while, because these voyages, they do take a little while. So let's get going. So what we're going to do this evening is we're going to start with Mars. I'm not going to talk to you about Earth's moon, because I think that's been done to death, and I'd rather talk about ones further out in the solar system. So we'll start with Mars and work our way out to Pluto. I'll be taking you on a guide of the moons, not all of them, obviously, but I'm going to be pointing out some interesting ones and what I find particularly interesting about them. So we start with Mars, which, as we know, has two moons, Phobos and Deimos, which mean fear and terror, respectively. After all, Mars is the god of war, so you would expect those sorts of titles for the moons. Then we go to Jupiter, which has currently 92 known moons. Saturn is the king of the solar system in terms of moons, with 146 of them. Uranus with 28 known moons, Neptune with 16, and Pluto with 5. So let's start our voyage by just hopping over to Mars. And Mars, as we know, has two moons. I'd like to talk to you about one of them in particular, which is, of course, Phobos. Now, Phobos is a very interesting moon for lots of reasons. Firstly, you've got all the data here. Its size, it's roughly 27 kilometers by 18 by 22. It orbits Mars once every 7.6 hours, discovered in 1877. But unfortunately, its orbit is just a little bit too close to Mars, and Mars is going to tear it apart in about 10.7 million years. Not that that need concern us. What I want to draw your attention to in this photo of Phobos, two things. This is an enormous crater on Phobos called Stickney, and notice around the edge of it these white deposits. At the moment, nobody knows what these are. You would think we would know this by now, but the fact is we don't know what they are. Notice as well, radiating away from the crater, you've got lots of grooves. Let's have a closer look at these. So this is the whole moon of Phobos. The crater that we've just looked at, Stickney, is at the right-hand end, and you can see those white deposits. Notice as well that the whole moon has got a series of grooves running across it. And just point them out here. Some of them run for just about the whole length of the moon. It's as if somebody's got their fingers and with their fingernails just sort of gouged the surface of the moon. We've no idea what causes these, and we've no idea what those white deposits are either. So this is one of the reasons why Phobos is actually quite mysterious. Let's have another look at something very interesting with Phobos. This is Phobos eclipsing the sun as filmed or photographed, because it's a stop motion photography effectively, by the Perseverance rover on Mars. So this is the Perseverance rover looking up and seeing Phobos pass across the face of the sun. And that you can see the sun very clearly there. You can see lots of sunspots on the sun. But I thought this was a lovely sequence of photographs that have been stitched together into a movie. Phobos eclipsing the sun as seen from the surface on Mars. Now, if we zoom in on the surface, we see on the right-hand side these white deposits, and the grooves on the left-hand side, you can see that. But also, I've marked them here. I don't know whether you can see this. There are what look like two parallel chains of craters, as if something has impacted Mars and sort of dropped bits of itself off as it was heading over the surface. And you've got definitely two parallel chains of craters there. Very, very strange. And we've seen these on other planets where an impactor has broken up as it's approached the surface of a body, leaving behind craters, but never two parallel series of craters like this. So these are all really strange things about Phobos. Here it is again. There's the crater Stickney, 9 kilometers across. And just a clearer view of it there. That impact of whatever struck Phobos to make that crater that we call Stickney very nearly split Phobos apart. It must have been something absolutely huge. The other moon is Deimos, of course. This is a lot further out. It goes around Mars once in 30 hours, and it's only 12.5 kilometers across. So it's quite a bit smaller than Phobos. But again, it's a bit mysterious because it looks as though it's covered, the whole surface is covered in some sort of deposit. And if you look at the craters there, you can see they're sort of filled in with something. So, you know, unfortunately, no spacecraft has ever got closer to Deimos to give us more data. This is about the best view we've ever had of Deimos. So this again is a bit strange. Here's a lovely sequence. This is Phobos passing in front of Deimos as seen again from the surface of Mars, by this time by the other rover, the Curiosity rover. So this is Phobos transiting Deimos in real time. It's a bit jerky because the rover only took photographs every few seconds. So it's a bit jerky, but that's another beautiful sequence. There are lots of mysteries about Phobos, and recently an explanation has come about as to why Phobos is so strange. Firstly, weird thing about Phobos, it doesn't reflect light evenly. Now, most asteroids and other moons reflect light on average quite evenly. Phobos doesn't. It's got some strange reflective properties. It's slightly brighter overall when the sun is overhead. Now, this is again something that's very unusual about Phobos. The surface is granulated like sand. So it's got something on the surface that's very akin to sand. And why should that be there? What's gone on there? And a group of scientists only last month published a paper in which they suggested that the reflective properties of Pluto are almost identical to Comet 67P. You may remember Comet 67P. In other words, what they're suggesting is that Phobos is actually a comet nucleus, an ancient comet nucleus, because its reflective properties are identical to comets. They call the Jupiter comets because Jupiter disrupts their orbit in some way. There's a group of comets that have their orbits disrupted by Jupiter, known as Jupiter comets or Jupiter-like comets. Well, 67P was one of them, and Phobos in reflective properties is almost identical. So could it be that when we look at Phobos, we're actually looking at a long dead comet nucleus? And if that's the case, does it mean that Deimos could be a comet nucleus as well? Or could there be two bits of the same body that at one point split apart, giving Mars two moons instead of one? We don't know. There's a lot of research to be done yet. But the fact that the reflective properties of Phobos fit those of Comet 67P almost exactly cannot be ignored. So very, very interesting theory. Lots of work to do yet. Now, before we move on to the outer solar system, I want to just, recognize those wonderful machines that have given us all the images of the outer solar system that we're about to see. So the Voyagers 1 and 2, of course, the Trailblazers, the legendary Voyagers, now our first interstellar ambassadors on their, because they've left the solar system, on their way to the stars. We had Galileo, which investigated Jupiter and its moons in the 1990s. We had Cassini, which spent 13 years at Saturn, and of course dropped the European Huygens probe onto Titan. New Horizons, of course, went to Pluto and investigated Pluto, and then went on to visit Arrokoth, a Kuiper Belt object. And they're still looking for another Kuiper Belt object that New Horizons might be able to visit in the future. Nothing found yet. There was a threat a little while ago to downgrade the status of New Horizons to a solar observatory, but I think that threat is rescinded now. They want it to carry on doing research into the Kuiper Belt. So we're just hoping that some astronomers can find a body that it can visit in the future in the Kuiper Belt, because actually it's quite a way through the Kuiper Belt now. It hasn't got many years left in the Kuiper Belt. Juno, NASA's wonderful Juno probe, which has been studying specifically the interior of Jupiter, about which we knew very little, but now about which we know a lot more. JUICE, the Jupiter Icy Moons Explorer, on its way to Jupiter to visit Ganymede, Callisto, and Europa, and study those each in turn. And then, hot on its heels, the American Europa Clipper, which is specifically going to put itself into orbit around Europa and study it for a few years. So these are the wonderful machines that we've sent out to study the universe by proxy for us. So let's move on to the first of these outer planets, Jupiter, which, as we know, has 92 known moons. These are, as I'm sure you know, the Galilean moons. These are the four innermost, brightest moons of Jupiter that you can see with a pair of binoculars, discovered by Galileo. I want to talk about one of these today in particular, and the one I want to talk about is Io, the so-called shape-shifting moon. It's called the shape-shifting moon because it's squeezed and stretched by Jupiter's immense gravity so that its shape actually changes. This generates enormous heat inside the moon, and Io is a volcanic moon. It was the first moon, first world beyond the Earth to have known to have active volcanoes, and it's a fascinating little world. It's about the size of our moon. It's the innermost moon of Jupiter. It orbits at a distance of about 422,000 kilometers from Jupiter. And of course, being so close to Jupiter, it's tidally locked so that it always keeps the same face facing Jupiter, much as our moon does with us. Now, It has more than 400 known active volcanic domes, or what are called pateras, which are volcanic pits. Could be as many as 1,000. There's a lot of volcanism going on this moon because of that intense heat inside it, generated from its crust being stretched and squeezed by Jupiter's immense gravity. It's resurfacing the surface with all that volcanic activity at a rate of about a few centimeters per year. One of the biggest volcanoes on Io is called Prometheus, and there you can see the plume of it erupting. And here's actual real-time observation of Prometheus erupting. And look at that, you're actually seeing a volcanic eruption on a moon of Jupiter. And there are lots of other volcanoes. If we look at a geological heat map of Io, you can see here that the orange and red circles are the hottest parts, and the blue and the black, the coldest parts. But as you can see, there are a lot of heat sources there, a lot of volcanism, which is raging all the time. Io is not a pleasant world to visit, so we're not going to stay too long there. Just to show you some of these volcanoes, Ra Patera, the shield volcano, the largest shield volcano in Io, 250 kilometers across. Then we have Loki Patera, a shield volcano. This one is 202 kilometers across, but it's got this active lava lake. And this volcano is creating 1 square kilometer of new surface crust on that lava lake per day. So what happens is that the surface of the lava lake cools and forms this crust. The crust then acquires mass, it gets too heavy, it falls back into the lava lake. This on its own can generate volcanism. But the main volcanism from Loki Patera, as it is for a few volcanoes on Io that do have these volcanic lakes, come from underneath the lake. So the lakes actually erupt. Now, if we just zoom in on this, you can see that this is in fact a lake with a crust forming on it. But recently, NASA's Juno probe made some measurements of this crater lake, and NASA did a visualization showing us what it looks like, and it looks like this. This lava lake is as smooth as glass, and it's got this, as I said, this crust in the middle of it. An amazing image. Well, it's a visualization from the data that Juno made when it flew past Io, I think last month or the month before. So there's this beautiful lava lake, a couple of 100 kilometers across. Io is such an interesting world. This is Pele Patera. It's 28 kilometers across, and in the background you can see the volcanic plume that it's generated. You can't see it in the foreground because of the brightness levels, but you can see it silhouetted against the horizon there. Pele Patera is only 28 kilometers across, but it's one of the most most volcanically active areas on Io. And there's a lovely image, which I believe was a Voyager image of Io above the clouds of Jupiter. It produces 100 times more lava each year than all of Earth's volcanoes put together. Just imagine that. So it's permanently erupting. And scientists believe that fueling all of these volcanoes, about 30 to 50 kilometers under the surface, is a global magma ocean that is permanently there, that is feeding magma to all those volcanoes. Unbelievable little world. So we're going to leave Io now, and we're going to leave Jupiter, and we're going to go on to Saturn. Now, for me, Saturn has been the high point of solar system exploration in the last decade and more, because the big surprise at Saturn was that Saturn, beautiful ringed planet as it is, was not the star of the show as far as Cassini, the space probe Cassini went. The moons became the star of the show of the Cassini mission. And I want to take you through some of them. This is a representation of just some of the moons of Saturn. As we know, it's got 146. But these are just some of them. Notice how close they are in orbits to each other, a lot of them. So it's a fairly packed neighborhood. Now, just take you through some of the images from the Cassini mission, which I think are beautiful. So this is Titan, Mimas, and Rhea. This is Titan and Rhea. These are all Cassini images. Some of them have been processed into color. Others have just been left as black and white because they haven't got the money to process every single image. But I think a lot of these actually look better in black and white, to be honest. So this is a lovely image. It's quite a noisy image, but it's one of my favorites. This is Titan, Dione, and Mimas. And if you're wondering where Mimas is, if you look towards the bottom, sort of center-ish, you can just about see it through the noise as a little crescent. Titan, Dione, and Mimas. Beautiful image. I hope somebody cleans that up one day, because I think that would be stunning if it were cleaned up. Another one that's not quite so clear, but this is Rhea and Dione. Lovely image of Tethys and Saturn, with Tethys just hanging above the rings of Saturn there. Rhea with the rings in the background. Beautiful image again of Titan and Saturn with the rings very, very clear there. This is one of my absolute favorites. This is Mimas and Saturn. And I love this image because, first of all, in the foreground at the bottom, you've got the rings. Behind them, you've got the shadow of the rings on the surface of Saturn. And there is little Mimas, that little moon that looks like the Death Star, hanging above the blue clouds of Saturn. And one of the discoveries that Cassini made was, in fact, that the northern hemisphere skies of Saturn are actually blue, as you can see, very pronounced blue. Let's just zoom in on this so we can see it a bit better. So a definite blue color to the northern hemisphere skies. These are due to chemical reactions not dissimilar to what we get on the Earth, although the chemicals are different. So let's just zoom out again. So this is one of my all-time favorites, Mimas and Saturn, a really haunting image, I think. Now, this is a really weird moon. When people look at this normally, they say it's not real. It can't be real. Yes, it is. This is a moon of Saturn called Pan. And it looks like a UFO. It's really weird. And it's a genuine image. And how does it get like this? Well, the only theory that's come forward so far, but, you know, there's not a lot of evidence so far for it because we need to do more research, is that the moon once had a ring that then collapsed onto its equator. And this is what we see circling the moon. It's really weird. It's also been called the ravioli moon because if you look at these images of Pan, it looks like ravioli. But again, very, very strange little moon. It's not the only one that is weird in this sort of way because we have Atlas as well, which is a bit flatter. But again, you know, we're not sure how moons get to be sort of frisbee shaped or flying saucer shaped like this. It's really strange. But, you know, these moons are so far away that we can't study them up close. And this is the best images we're going to have of these moons for a long time. So there's another image of Atlas there. Really strange moons. Saturn is full of surprises. And nobody expected this either. Hyperion. It looks like a sponge. And the idea behind this, what they think happens with this, is that the material that Hyperion is made of is quite porous. And when something slams into it, instead of it making a circular crater, it's actually able to burrow vertically down without making a big explosion that would create a circular crater. Just goes straight in because it's porous and soft. So you get these sort of cylinders instead of round craters representing impacts. It's a very, very bizarre moon. Now, Cassini saw this on its way into Saturn when it arrived at Saturn in 2004. And it didn't really get another chance to fly in the same orbit to have another look at Hyperion. But it did manage to get a few images, which you know, are just amazing. This is a moon called, like the volcano on Mars, it's called Prometheus. This is actually a beautiful image. This is Prometheus rising through Saturn's F ring. Each ring of Saturn is given a letter, and this has a strange effect on the F ring. And what it actually does, it creates these so-called streamers. As it moves through the ring, particles in the ring sort of get out of its way due to gravity, and it leaves these sort of trails or streamers behind it, and it creates quite a few of them. You can see them here. This is the F ring, and you can see all the streamers that Prometheus has made in subsequent passes through the ring, and there we are. This, of course, is a beautiful image of Titan, backlit. And then we move on to Iapetus. Now, we knew before Cassini went there that Iapetus was a very strange moon. One hemisphere is as bright as snow, and the other hemisphere is as dark as coal. And this has never been understood, but it appears to be something to do with these dark deposits that are being dropped on Iapetus on one hemisphere that make it so dark, because the other hemisphere, it's ice. So it's very, very, very bright. But that's not even the weirdest thing. We don't understand exactly how that happens, but it's not even the weirdest thing about Iapetus. This is probably the weirdest thing about Iapetus. There's an equatorial ridge going all the way round Iapetus, round its equator. It's taller than Everest, and it's about 20 kilometers wide. And here it is again. These are all Cassini images. Here it is again. And here you get a very clear view of this ridge going right the way around the equator of Iapetus. We think it goes all the way around. It may not, but from what Cassini could see, it goes all the way around. And this is a close-up of that equatorial ridge. This is one of my favorite images as well from the Cassini mission. Absolutely stunning image of this equatorial ridge. How on earth did that get there? Because if you look at this image again, it looks like there have been two halves of Iapetus that have been welded together with the weld line still showing. The idea again is that Iapetus once had a ring which collapsed onto the equator, leaving behind all the debris which formed this mountainous equatorial ridge going right the way around the moon, which is certainly really weird, but I'm just in love with this image. It's just beautiful. Let's move on now to a very famous moon called Enceladus. Now, all the data is on the right-hand side. It's got a very, very young surface. As you can see, there are a few craters, but not many. So this is a young surface that's constantly being replaced. It's tidally locked to Saturn, meaning, again, it always keeps the same face towards Saturn. And that's, again, is not the weirdest thing about it, because what Cassini discovered was the fountains of Enceladus. Towards the south pole of Enceladus, Enceladus is gushing out huge quantities of ice crystals and water vapor into space. You can see them here. They're like geysers on the Earth. Now, this was quite hard to believe at first, but it's absolutely true. Cassini later flew through one of these plumes emanating from the south pole of Enceladus and sampled what was there. And it's led to some really interesting discoveries. So let's have a look at what this is all about. There's another view of the fountains of Enceladus with that huge quantity of water vapor and ice crystals. You can see they're gushing out of the moon all the time. If you look at a temperature map of Enceladus, on the left we see what it should look like, with the orange areas being the hottest. But on the right, we see what it actually looks like. Most of the heat is coming from that south polar region. What on earth is going on there? This is an artist's impression of what's going on at the south pole of Enceladus, with these plumes gushing out of Enceladus. Here's the region we're talking about. And there are cracks along the south pole of Enceladus, which are referred to as tiger stripes. Now, as you can see, it's quite a good name. These are stripes. On the left-hand side, you can see them in close-up. They've got names like Baghdad sulcus, Damascus sulcus, Cairo sulcus, Alexandria sulcus. Sulcus is basically a crack or a depression. And there in the middle, you can see where the South Pole is. The material, all that water vapor and ice crystals are coming out of these cracks. And if we just zoom in a bit, you can see here the South Pole in the center. There's quite a complex nature, a lot of cracks there. And let's have a look at one of them in a bit more detail. This is Baghdad sulcus. These tiger stripes are typically about 2 kilometers wide and 500 meters deep. But obviously, if we say 500 meters deep, they're connecting with something below that, because this is where all of that water vapor and ice is streaming out of, as we saw in the artist's impression. And this is a more general look of the same area. You see, it's a really complex terrain with all of these cracks going everywhere. So what on earth is going on? Well, what scientists think is that under the surface, under the crust of Enceladus, is a global ocean. Let me just zoom in on this a bit so you can read it. So starting with number one, what the thing happens is that cold water from this ocean leaks into the porous rocky core of Enceladus. It then heats up, and that hot water rises in narrow plumes and interacts with rocks. Then that creates at the bottom of the seafloor hotspots, and that heat and rocky material is then transported through the ocean towards the surface. There is localized heating on the edge of the ice, and eventually that material finds its way through cracks in the ice and gushes out into space. So without there being a global ocean under the ice of Enceladus, it's difficult to explain exactly what's going on. So this is the favorite explanation. What we think there are, if you know about the black smokers along the mid-Atlantic ridge on Earth, then we think there are similar things on the ocean floor of the Enceladus Ocean, although they're not black smokers, they're white smokers, but the same sort of thing. And as we know, the black smokers along the mid-Atlantic ridge on Earth, they're a haven for all sorts of life that are extremophiles that have adapted to living in boiling water and no oxygen and a terrible environment, but they're teeming with life. So could it be the same on Enceladus, that life could have started here? We don't know. And we just need to get out there and find out, basically. But this is what they think at the moment. Just to give you some figures on that, the ice shell is between 21 and 26 kilometers thick, but towards the South Pole, in the region of the Tiger Stripes, they think it's only about 5 kilometers thick. The global ocean is about 37 kilometers thick. It's got a pH of 8.5 to 9, so it's a little bit alkaline. The rocky core has got a density of 2,400 kilograms per cubic meter. The hydrothermal vents on the floor of the ocean ejecting water at about 90 degrees C. About 100 jets in the Tiger Stripes. Larger grains of material are vented out into space in what are called collimated plumes, and the smaller grains are vented out in what are called mixed plumes up to about 40 kilometers. 93% of all that material that's vented out of Enceladus falls back onto the surface, coating the surface, which is why it looks so new. So the surface of Enceladus is constantly being renewed, which explains why we don't see many craters there, because they're covered up by new deposits falling out of the sky of Enceladus. And just lastly, here are the vents on that ocean floor of Enceladus, the white smokers. When Cassini sampled the plumes, the material that it found had been in contact with rock. So there had been some sort of water-rock interactions, which supports the theory that we just talked about. So, you know, we need to do a lot more exploring of Enceladus because it is a potential harbor for life. So really exciting stuff. And also, All that material, the stuff that doesn't fall back to the surface of Enceladus, creates a ring of Saturn called the E ring. And we can see Enceladus here gushing out material and the actual E ring of Saturn that it forms. So that's where the material that doesn't fall back to the surface goes. It forms this E ring around Saturn. What we'll do now, we'll move on to Uranus. Now, Uranus has 28 known moons. Here are the bigger ones: Miranda, Ariel, Umbriel, Titania, and Oberon. And I want to draw your attention to this one, which is Miranda. This is a bizarre moon. You can just see by looking at it. Why on earth is that so bizarre? Well, what the thing happened is that Miranda has been broken up by collisions with other objects several times in its history. Each time it's put itself back together again under gravity. And we've ended up with this really bizarre jigsaw puzzle of a world where bits of terrain don't seem to fit together in the right places. Really bizarre. It's 235 kilometers across, and you've got examples like this. This formation has become known as the racetrack. We don't understand how these formed, by the way. The thing on the left of this image is called the chevron for fairly obvious reasons. And you've also got the solar system's tallest cliffs here. They are 20 kilometers high. 20-kilometer cliffs of pure ice. Let's zoom in a bit so you can see those in a bit of detail. It's not a great image. This is a Voyager image, but you can see, if you squint a bit, get rid of the pixelation, those are sheer rock walls 20 kilometers high. And they're known as, they have the official name of Verona Rupes. And here's an image of the far future where people are basically skydiving off it, just jumping off. Now, this would be fantastic. I wonder if you can guess how long it would take to fall to the bottom of a 20-kilometer high cliff, given the low gravity of Miranda. Well, I can tell you, it would take you 12 minutes to reach the bottom. When you hit the ground, you would be falling at 124 miles per hour. It's slower than Earth's terminal velocity, thanks to this weak gravity. But obviously, if you hit the ground at 124 miles an hour, it's enough to kill you. So you would have to have probably not a parachute because there's no atmosphere. You would have to have some other way of slowing your descent when you got towards the bottom. But it's nice to think about. I wonder if anybody will actually do that in the far future. I'd never do it for fairly obvious reasons because I want to live. But I bet one day somebody will do it. So there we are. So that's Verona Rupes, 20-kilometer high cliffs of ice. Let's move on now to Neptune. Now, Neptune has got 16 known moons, and I want to talk to you today about Triton. Now, this, believe it or not, this is a good pub quiz question. What's the coldest place in the solar system? And the answer is not Pluto, as you might expect. It's actually Triton. Triton, although it's much closer than Pluto, is actually colder. And, you know, if you go to a party and you want to strike up a conversation with somebody, you could lead with that. Do you know what the coldest place in the solar system is? Good luck with that. The surface temperature is minus 235 degrees C. This officially makes it the coldest place in the solar system. Again, it's tidally locked with Neptune. It's about 354,000 miles away from Neptune on average. It's 2,706 kilometers across, and it orbits around Neptune in a retrograde motion. In other words, in an opposite way to all the other moons. This gives you a clue that there's something unusual about it, and there is. But let's have a look. Firstly, its temperature is completely unexpected. The fact that this world is the coldest place in the solar system. But there's something else. Now, if you look at the terrain, this sort of mottled terrain towards top left of this image, I'm going to show you another piece of mottled terrain. This mottled terrain is from Pluto, and they're very, very similar. And what scientists believe is that Triton is actually a Kuiper belt object like Pluto. It's very similar to Pluto in lots of ways, that was captured by Neptune's gravity. So they're actually Kuiper belt objects. They have very, very similar types of terrain. So that would explain a lot of things about Triton. It came from much further out from the Kuiper belt. Perhaps it was in a collision with another body that forced it inwards into the solar system. We don't know. But there's something even more odd about Triton. Let's zoom in and you can see what they are. Now you see these black streaks across the southern hemisphere. They all radiate in the same direction. What on earth was going here? Well, Voyager found out. Because if we now have a look at this, these are geysers. And here's an animation that Voyager, or it's taken from Voyager images. You can see that black trail is a geyser trailing downwind, as it were. And scientists couldn't believe it. This little world Triton has active geysers spewing gases out a long way into the sky. Now, how does that actually work? Well, what the thing happens is that even though Neptune is so far from the sun, what happens is that sunlight acts on the ice on Triton, heating up gases underneath that ice. And the gases expand and eventually rupture the ice and come out in the form of a geyser under pressure. This has given us a fantastic lesson about the outer solar system, because this is the coldest place in the solar system. And yes, it is frozen solid, but it's not dead. There is energy, there's activity, there are dynamic processes going on. We expected the outer worlds of the solar system to be balls of ice with no activity, nothing going on, because they were too far from the sun, and we were completely wrong. There are dynamic processes on Triton, there are dynamic processes on Pluto, and all driven by the sun, even though from the outer depths of the solar system, the sun is just a really bright star in the sky. It's enough to make these processes happen. There's activity here where we least expected to find it, and that is a really valuable lesson that spacecraft like Cassini have taught us. There's no truly dead place in our solar system. There's stuff going on everywhere, not expected at all. Let's move on now to our last world, which is Pluto. It's a beautiful planet. I'm not going to get into the debate whether Pluto's a planet or not. If you want to know about the whole history of the debate, I've actually made a video for Space Oddities, which is on our channel. Go and have a look at that, because I tell you the whole story in probably more depth than I wanted to originally. It's 38 minutes long, but it gives you the whole background to the debate over whether Pluto is a planet or not. Here are the 5 moons of Pluto in comparison with the size of the Earth. So Pluto itself, 736 miles across radius. Charon, Hydra, Nix, Kerberos, and Styx. As you can see, compared to Pluto, Charon is really big. In fact, it's half its size, as you can see in this lovely image from New Horizons. In fact, you could think of them as a double dwarf planet rather than planet and moon. It's got the biggest size to planet ratio in the solar system. No other moon is this size in relation to its parent planet. So you could consider this a double dwarf system. It's 1,212 kilometers across, and Charon is, again, a really interesting moon. And let's have a look. You see, minus 230 degrees C is warmer, 5 degrees warmer than Triton. So this goes to demonstrate that Triton is indeed the coldest place so far discovered in the solar system. It rotates once every 6.387 Earth days, and its orbital period is the same. In other words, like our moon, Charon always keeps the same face turned towards Pluto. It's tidally locked. And it orbits at a mean distance of just under 20,000 kilometers. This is a lovely painting. This is one of my favorite paintings, I think, of all time, of Charon over the skyline of Pluto, over the horizon of Pluto, with the sun, as I said, just like a bright star in the sky, with the ice of Pluto in the. I think this is an absolutely beautiful image. And I did actually manage to track down who created this image, and I sent him an email to say, I just wanted to say congratulations. I think this image is really beautiful and really haunting. He never replied, but at least I tried. I'm one of these people that's always in favor of, if you like something, tell the creator who did it. But he never replied. But I'd love to have a big print of this on my wall. I think it's a really evocative, haunting image. Anyway, this is Sharon. Now, as you can see towards the bottom, going from about the 8 o'clock position up to about the 2 o'clock position, there are massive canyons and cracks in the surface of Sharon. We'll come back to those in a little while. But there's something on the limit about the 4 o'clock position that I want to draw your attention to. This is really strange. We'll come to that in a second. I first of all want to talk about these. These are tholins. What we think happens here, it's a big stain, a reddish stain across the North Pole of Sharon. What we think happens is that methane leaks from Pluto's atmosphere and deposits itself on the North Pole of Sharon, which then interacts with sunlight and forms these organic compounds called tholins. We see them on Pluto as well. And it's like a chemical goo of organics. And we think that's where the tholins come from directly from the atmosphere of Pluto. Now, as I said about the 4 o'clock position, let's zoom in. What on earth is going on here? What is that? Well, this turns out to be something. Oh, this was completely unexpected. So bizarre. Let's have a clearer view of it. What this is a mountain in a moat. Essentially, there's this huge depression in the ground with a mountain in it. It looks like somebody's got that mountain and just sort of pressed it into the surface of Sharon, making a depression. That's not what happened, obviously. This is not an impact. That mountain is not some sort of asteroid, because it would have made a big round crater, as you can see the other round craters here. We don't know how it got like this. Let's see if we can get some more detail on it. There we are, the mountain in the moat. Really bizarre, never seen anything like this. Love to know more about it, but again, you know, we're not likely to get out that way again for some considerable time. It's very mysterious, and it's been given an official name by the International Astronomical Union. I'll say that again, International Astronomical Union. It's been given the perfect name to conjure up mystery. It's been called Kubrick Mons after Stanley Kubrick, who brought us, of course, the most mysterious film of all time in 2001: A Space Odyssey. I'm wearing a 2001 t-shirt at the moment, just realized that. Anyway, so this is Kubrick Mons, the mountain in the moat, as it's now called. Really strange. So let's go back. Those cracks, and they are massive canyons and cracks across the surface of Sharon. What scientists think happened was that Sharon had an interior ocean of water and ammonia, which then froze. And as we know, when something freezes, it expands. And that expansion caused the whole crust of Sharon to crack like the surface of an egg. It's like an eggshell. But, you know, again, all this is being investigated all the time. But that's the best theory at the moment, that the ocean is still there under the surface of Sharon, but it's completely frozen, of course. But that has undergone some incredible torture. So just to finish today, just to sum up, the solar system is home to an incredible variety of planetary moons, far more variety than was thought or predicted just a couple of decades ago. The history and evolution of these moons is written large across their surfaces in stories we're only just beginning to understand. They speak of an unimaginably violent history of the early solar system. They speak of tortured worlds, frequent collisions and rebirth. But they also tell us of their potential for creation in the form of ocean worlds like Enceladus and Europa and Ganymede and the other ocean worlds of the solar system that we've come to realize are ocean worlds just in the last few years. And perhaps they've created life, which would be the ultimate creation story of the solar system. If life has arisen twice in the same solar system, you cannot think any other way, but it's everywhere in the universe. And we need to get out there and visit these moons and find out exactly what their stories are. So there we are. So I'll gladly take any questions now. So thank you so much.
Thank you very much indeed, Andy. A beautifully illustrated talk. Must take ages to put all those images together. And I want to thank you for all that effort and amazing. I'd seen some of the images before, some I hadn't seen, and you reminded me how crazy some of these moons are. We look at them in our telescopes, they're just tiny dots. But those craft have really revealed them in all their glory. So we've got about 10 minutes for questions if people want to either shout them out or ask them in chat. I see there's at least one question in chat. Do you want to read the questions in chat yourself, Andy, or should I read them out to you?
If you could read them out to me, that'd be great. I can't quite see where the chat window is.
Sorry about that. I turned off my microphone by mistake. So Paul Griffin asks, is it possible retrograde moons are captured asteroids or comet remnants?
Yes, indeed. Indeed. Whenever you see one of those, you've got to think there's something different about that. Because, we don't know a lot in great detail about how these moons form in the first place. We've had difficulty enough understanding how our own moon formed, let alone, one's far off in the solar system. But if you have, a retrograde moon that's going in an opposite direction around the planet or the others, that's an immediate red flag, if you like, that there's something different about it. And we think a lot of these moons, well, not a lot, but certainly several, are indeed captured asteroids or comet remnants, like Phobos, we now believe could be a comet remnant. But that doesn't go in a retrograde motion in relation to Deimos. But if Deimos is part of the same comet, that would explain why they're both going in the same direction. So it wouldn't look anything unusual. But yes, to answer your question, definitely, if these retrograde moons could well be captured asteroids or other bodies, yes.
Well, look, we've got a few questions coming in. We want to take the questions very quickly because we want to leave time at the end to tell people about the double planet in morning skies, the Perseids peaking tonight, and of course the aurora. It's still raging, so I'll fill people in on that after the Q&A. I'll keep it brief. Most of the stuff is in our magazine as well anyway. But Sandra asked the next question: will our moon eventually stop blocking out the sun because it moves away from the Earth at about 2 centimeters per year? And I can add to that because I think I know the answer, but I see very conflicting differences in the time period that's going to happen. Maybe you can enlighten us all, Andy.
Oh, I don't think I could give you a time period because I've seen so many estimates as well. I've never actually calculated it myself. I don't think I could actually. But yes, Sandra, you're absolutely right. So in other words, the time window, if you like, when we can see total eclipses of the sun is only a finite period. And in the far future, because as you said, the moon's moving away at 2 centimeters per year, we'll first of all only be able to get annular eclipses and then partial eclipses as time goes on. So yes, the days of solar eclipse. And don't forget, the Earth is the only planet on the solar system where we can see total eclipses of the sun, whose moon completely covers the sun. It's the only place. And so even that is temporary, unfortunately.
Yeah, I think I heard that I think I heard the time period is 700 million years. I just did a quick search and see Sky and Telescope magazine are saying 620 million years. So let's say half and 1 billion years.
David, you could tell me a million years and I'd believe it.
Well, look, we should be okay with total eclipses for the foreseeable future. Next one on Irish soil is September the 23rd, 2090. So
is it really?
Yes, yeah.
Well, I hope you're all going to come to Spain in 2026.
Yeah, exactly. Even better. We'll have more about that later on.
Yeah.
So more questions. Tom asked, does Venus have moons? If not, why?
It doesn't, and we don't know why. Simple.
Great. Then we can go straight on to Susan's question, which is, life possible? Life being not what we think?
Maybe. Well, yeah, I mean, you've got to ask the question, what do you mean by life? And we think we know.
Sorry, Andy. And then Tom asks next, brilliant
Oh,
talk. Looks like moons are our most likely candidates for life and not the planets. What is
yeah,
the
definitely,
best bet, do you think? Same question.
most definitely, Tom. Yeah, well said. This has been one of the big surprises of our reconnaissance of the outer solar system over the last few years. That it's the moons that have been the star of the show. It's the moons where we're likely to find life more than, obviously we can't find it on the gas giants, but Mars maybe, but it's the moons that are the stars of the show, definitely.
And Hosea asks about planets around, sorry, moons around other planets. I think you covered that one already. Ed Mole, congratulations on a brilliant talk. Could Enceladus eventually lose all the water of its oceans due to the plumes and gushing?
Yes, I guess so. Yes, absolutely. Yes, it's got a finite amount. But I mean, we have to ask the question, does any of the ice find its way back into that ocean through cracks in the ice? Perhaps there are some cracks that go all the way down to the ocean, and the ocean could refill from the surface ice. We don't know. But if that doesn't happen, yes, there's a finite supply of water, definitely. By the way, it's ejecting about 1,000 kilograms of material per hour. It's about a ton per hour. So that's quite a lot.
Great. Well, I think that's, I think, the formal questions over. One quick point I might just throw in. When Asaph Hall discovered the moons of Mars, it was the late 1800s, they were confirmed, I believe, by an Irish amateur astronomer somewhere in the suburbs of Dublin. I'm trying to remember his name. I had a quick look on the Wikipedia page and couldn't find it there. So I know Tony Ryan, who's giving a talk at Starbecue, did some research on this. And anyone can edit those Wikipedia pages. So it might be a nice local angle.
And did you also know that of all people, Jonathan Swift, author of Gulliver's Travels, predicted the discovery of 2 moons of Mars, which is quite amazing.
That's right, yeah, and Gulliver's Travels, and yeah, of course, was he the dean or whatever they call him of the? Is it the No, it's the St. Patrick's Cathedral in Dublin.
That's right.
He was based in Armagh for a time as well. Lots of nice Irish links there. But Andy, look, that was an incredible talk. Really enjoyed that. Beautifully pictorial. And the kind of talk we want to spread with the general public, if that doesn't get them excited about space, nothing will.
I agree. Well, I think the last couple of times I've spoken to you, I've talked to you about fairly heavy stuff like gravitational waves and black holes. So I thought we'd just do a pictorial one this time. There's something a bit easier.
Well, thank you very much.
My pleasure.
Really enjoyed that. So we'll just spend 5 more minutes telling you about what's happening in the sky and then events coming up like the Starbecue at the end of the month. I'll keep it quick. Should I turn on my video? Because most of the information is in the magazine. So those you got the magazine, great. If you haven't, you can order it now. It'll be sent to you usually next day. And there's quite a few things in the Sky Diary pages. But I always tell people is when you get the magazine, especially if you're a beginner, turn to page 22, where you'll see the highlights box. And even if you're rushing out, have a look at that. And it'll tell you at least, anything important. For instance, next month, September, there's an eclipse. October, there's a bright naked eye comet. November, we're going to have a Venus coming into evening skies. December, we've got the Geminid meteor. It just goes on and on and on. So that's my tip for what to see in the sky. And what is there roughly at the moment? Well, just go over the planets. Jupiter and Mars are getting very close in the morning sky. So they're not up till after midnight. Saturn is already in the evening sky because it's going to be the star of the show. I've managed to see Venus very low down. It really need a few more months for it to be seen. So Saturn is the main planet on view. The rest are in the morning sky. And I've been shocked that we haven't had lots more pictures or reports of people seeing this double planet in morning skies. So let me just check my notes. It is Tuesday. It's Wednesday morning and Thursday morning. Get up at 3 o'clock, 4 o'clock in the morning and look at Mars and Jupiter. Even 2 mornings ago, it was clear briefly. And the sight of this double planet Jupiter, brightest thing in the sky, and Mars, as bright as the brightest stars in the sky, so close, was already spectacular. They're going to get closer than the width of the moon, about 2/3 the width of the moon. That means if you've got a telescope, you'll be able to look at the two planets at reasonably high magnification, see both of their disks, the moon's appropriate enough for tonight, of Jupiter, all in the one field of view. And for us, it happened on 2 nights. They're almost exactly the same distance. Wednesday morning, Thursday morning. They're the ones to set your alarm clock for. But look tonight. So if you stay up watching the Perseids, and every night, there's a diagram in the magazine showing them passing each other for I think about 10 days. So that double planet is extremely rare. Try take a picture on your camera phone. It should come out great. These are some of the brightest stars in star-like objects in the sky. Saturn itself is incredible. The rings are nearly edge on. I mentioned earlier that we won't see them when they're exactly edge on next March because Saturn's too close to the sun. So we'll have to wait another 15 years, 2039. So if you haven't got a telescope, come to the Starbecue and use ours to get that unique view. There'll be at least 4 of the big moons on view. I was just looking during Andy's talk. We'll tell you more about that at the Starbecue itself. I'm going to leave the Perseids and the Aurora to last. But remember, in your magazine, there's full details on the 20th of August, that's Tuesday next week, when Saturn passes behind the moon. Now, you'll see it very close Tuesday night. And as the night wears on, you're going to have to stay up late because it's around 4 a.m. That Saturn actually passes behind the moon. Now, the moon is nearly full, so it'll swamp Saturn a bit and you'll need a telescope to see it. But I have seen Saturn going behind the moon before, and it's an incredible sight. So that is definitely a highlight of the month. The moon is near the Pleiades. Mars was near the Pleiades recently. There's a beautiful sight, not just Jupiter and Mars, but the Hyades nearby and the Pleiades above it. Michael Murphy from County Fermanagh sent in a beautiful picture to be going into the next magazine, taken a few days ago, of the whole scene itself. Jupiter will be near the moon 27th of August, details in your magazine, and so will Mars the next night because they're still so close together. Mercury will make its best morning show just before our next lecture. By the way, these lectures are normally held on the second Monday of the month. So in the first week of September, Mercury's in morning skies, if you like, getting up at the crack of dawn. So the 2 big things left, the Perseids and the Aurora. I'm going to save the Aurora to very last because I want to refresh the screen and see what's happening with the activity. But the Perseids peak tonight. This shower happens every August. The moon will be out of the way because it sets around 11 o'clock, just as it's gotten completely dark. You'll see more from the countryside than you will in towns and cities, but there are lots of fireballs associated with Perseids because they're some of the fastest meteors we have. They hit us at 130,000 miles an hour. So you get long trails, and they can leave a glowing train behind them for several minutes. You might have seen our social media, someone from Scotland posted one of those today. I didn't know what it was. It's the smoke cloud, if you like, off the Perseid. People may remember, I think it was 2 years ago, we had a cover picture of an incredible Perseid, 2:14 in the morning, I remember well, because I saw the entire land in front of me light up. Behind me, there was a building, and when I turned around, the building had blocked my view of what's on the cover of the magazine back then. On our website, astronomy.ie, we want you all to count how many meteors you see every 15 minutes. This is how we know whether these showers are getting stronger or weaker, by the general public counting them. That's what I've been on radio the last week telling everybody to do. So the details, if you can remember our email address, magazine@astronomy.ie, the details are on the website anyway. So try and stay up as late as you can. I looked at the satellite picture a moment ago, and a lot of the country is clear. There are clouds yet to come in from the west, so people on the east coast might be able to see tonight's Perseids till dawn. Let's hope so. And there's expected to be perhaps 1 or 2 per minute. That's what I've seen of a good Perseid shower from a dark sky in the past. That's 20 times more meteors than normal, and it roughly halves every night thereafter. So there'll be 10 more than normal tomorrow night, 5 times more than normal the night after. That's still worth watching. So if you can stay up late several nights, do, not just tonight. And if there are any clouds around, the tip is look in the clear patches. They're called Perseids because the tracks point back to the constellation of Perseus, but they don't have to be anywhere near Perseus, which is over in the northeast. the start of the evening. So if there's a clear patch on the opposite side of that sky to that, look in that clear patch. I was doing that myself a few mornings ago, only saw a few that early on, but I must have seen at least a half a dozen Perseids already. Hopefully I'll get to see a lot more tonight. I'm trying to rush everything and cram it all in. There's a full article in the magazine about observing the Perseids. If you haven't read that, read it. That'll give you more background, get you ready for tonight. There's a bit about photography as well. I'll leave that to the magazine and the experts. So that's the Perseids peaking tonight. The Geminids are next big shower in December. But what about the aurora? Well, let's have a quick look and see what it's doing at the moment. There's a nice website on the Space Weather Prediction Center, a nice web page, where they have what's called the ovation model. And it's based on the radiation from the sun. They can more or less predict within a half an hour to an hour what it's likely to do to the aurora. And if you use that site, then there's a power, the amount of power the aurora is pumping into the Earth's atmosphere. And it's measured in gigawatts. During May the 10th, it shot up to 200, unheard of, over 200 in fact. I saw it peak today at 150, 160, which is nearly as good. The KP index, as it's called, those who are experts in aurora, hit 8 today. Now, 5, you start to see something on the horizon from Ireland. 6, you get a nice display. 7, it's a great display. 8 is the whole country sees it. It hit 9 on May the 10th. So it looks like it's still lasting. I'm seeing 109 gigawatts at the moment. And I've noticed if it gets above 50, my camera can pick up an aurora on the horizon. So I think we are going to have an aurora tonight. We've got to wait till about 11 o'clock for it to get dark enough to see an aurora. Wouldn't it be incredible if we had the Northern Lights and the Perseids on the same night? I'll definitely be up till dawn catching that double planet as well. There's so much to cover. Hopefully I've said enough. If anybody has any quick questions about any of that, I'll take them now. Other than that, I'll tell you about the next lecture on the Starbecue. Well, look, save your questions. Ask me after the announcement, because some people might want to leave. The big event for astronomy on this, the last day of this month, Starbecue, our annual barbecue under the stars. It's by far the biggest star party in Ireland every year. Hundreds, sometimes nearly 1,000 people come along to look through giant telescopes in a really dark sky in the Wicklow Mountains at the wonders of the universe, star clusters, galaxies. As I said, this year the star attraction will be Saturn, with those rings nearly edge on, a once in 15-year chance. There'll be a professionally catered barbecue. We have, I'm giving a talk on the universe. There's Rosemary Coogan, the new Northern Irish astronaut candidate. She's going to give a talk as well. Tony Ryan's going to talk about eclipses. There'll be trade stands, displays of photography, and all manner of things. It's a complete telescope festival, not to be missed every year. And we take over the GA grounds of Roundwood, County Wicklow, strewn the pitch with giant telescopes, and you can look at all these different things and enjoy some hot food 1,000 feet above sea level. So really looking forward to that. The price is going to go up the Monday of, it's on a Saturday, so the Monday of that week, the prices have to go up because our caterer needs to know. So you can book the early bird special right now for about 1/3 of the normal price for children. So go to astronomy.ie, our website, and book it. Get all your friends and family to come. It's very family friendly. You don't have to do anything. We do everything for you. We point the telescopes. You just look in and have a pretty unique experience of perhaps anywhere in the world to get a view in giant telescopes, thousands of times better than your eyes from a really dark sky. I probably left loads out, but there's a movie showing what it looks like on the website as well. Which you can enjoy. I think we have about 3 movies made so far. Certainly, I can't recommend it enough. And that's August the 31st, the last Saturday of the month. Our evening classes are beginning in October. They're enrolling now. If you're not a member, sign up for them. You get a magazine subscription included in the price. You'll start getting the magazine tomorrow. The Sky at Night's on BBC4 tonight at 10 o'clock, I mentioned earlier. And that brings me to close. And I'll hang around for a few minutes of questions if anybody has them. We're closing with the next lecture, which is on the second Monday of the month, September the 9th, not long after Starbecue. Hopefully we'll have recovered by then. And the question is, what has space done for us? It's been given by Mary McIntyre, who's from Oxfordshire, and she is an amateur astronomer, takes great pictures of the sky, and has also looked into this question that Andy showed a lot of spacecraft pictures of the moons. They're expensive, we spent billions on getting those pictures Andy showed, but human versions of those will be phenomenally expensive, probably in the trillions. And some people think we shouldn't be wasting our money on sending astronauts up. Others think it's very important. And Mary will explain all the reasons for that. Some very good psychology behind all this. So if you're interested in space exploration, book your ticket now on astronomy.ie. And don't forget, follow us on Facebook, Twitter, and X, where we'll predict the aurora every day, if it's happening or not due to happen, the International Space Station when it flies over, and any of those Starlinks soon after the launch, when you get 20 satellites streaming across the sky, following each other. Do get the magazine. It only costs about €1 a week. We're the world's most popular astronomy society. Get all your friends to join. We're always looking for new people. I think that's everything. What a month it's going to be. And if anybody wants to ask any questions, just unmute your speaker and shout them out. And thank you again to Andy for a brilliant.
My pleasure. Can I just say thank you to you and to Tom and to Laura and everybody, as always. And if anybody hasn't been to the Starbecue before, go, because it's wonderful. And when I went a couple of years ago now, it was fantastic day. I had a fantastic time. So
thank you very much. There you are, independent confirmation. We've been running this since 1992, would you believe?
Wow.
30 years now. So we think we've got the formula right. And, there's frequently asked questions on the website. What if it's cloudy? Doesn't matter. We figured out how to beat the Irish weather a long time ago. What we do is we run the whole event, barbecue, talks, everything else. And if it's cloudy, we actually set the telescopes up the following Friday or Saturday when we get the first one that's clear. So keep your weekends free the following week, just in case. And so we've always managed to show people the wonders of the universe at every Starbecue going back to 1992. No more questions? Great. Well, thank you all for hanging on, and we'll see you all at the next meeting and hopefully at the Starbecue as well. Good night, everybody.
Bye-bye, David. Take care. See you soon.
Thanks very much again, Andy.
Thanks, Andy.
Bye.
Thanks, Emil.
See you soon, guys. Take care, everybody.
Take care, Andy.
You too.
Okay, Laura, you can end the YouTube and I'll do the main screen.